Hello and welcome. Today we're going to be going over Kirchhoff's voltage law, or KVL as it's often called. Before we begin, it's a good idea to ensure that you have a good idea of what Ohm's law is and how voltage, current and resistance add in series and parallel circuits. The way we're going to do this is I'm going to go over the basic theory alongside a very simple example, and then we're going to go through 2 or 3 harder examples. In KVL, the main concept to consider is that when moving around a closed loop, the sum of voltage rises is equal to the sum of all voltage drops. The direction of movement does not matter, but by convention, a clockwise motion is usually used. The way that we assign whether a component is a voltage rise or a voltage drop is simple. When moving across the component, if we move from a negative voltage to a positive voltage, then it's a rise. If we move from a positive to a negative voltage, then it's a drop. If we're not sure, then just pick one. If we choose wrong, it'll have a negative value when we solve the equation later. Let's start by looking at this simple example where a 10 volt source is in series with a 1 kilo ohm resistor. From the start we can see that the resistor must have 10 volts across it, and it's also pretty clear which side is negative and which side is positive. So let's go through KVL for this. V rise in this case is equal to V source, which is equal to 10 volts. Assuming that we put the positive and negative sign around the right way, we should be able to read off the voltage across R1. V rise is V drop, so therefore 10 is VR1. But let's say that we didn't have our positive and negative signs around the right way. Now we assume that because of the direction we move through R1, that it's a voltage rise. So V rise equals V drop, V source plus VR1 is equal to 0, and so then VR1 is negative 10 volts. This is what I meant earlier. If you guess the signs wrong, then the value is negative, so just flip the sign and change it from either a drop to a rise or a rise to a drop. Let's jump into the deep end a little. Here we have a 10 volt source in series with a 1 kilo ohm resistor, which is in series with a parallel combination of a 5 volt source and a 500 ohm resistor. I'm going to assume the following signs for R1 and R2. Here we have 2 closed loops, so let's get started. For loop 1, let's start here. So moving clockwise, we go from negative to positive across V1, so that's a 10 volt rise. Then from positive to negative across R1, so that's a drop of VR1 volts. So finally we go through V2 but from positive to negative, so that's a drop of 5 volts. So 10 equals 5 plus VR1, and so VR1 is equal to 5 volts. For loop 2, let's start here. Moving clockwise, we go through V2 from negative to positive, so now it's considered a voltage rise of 5 volts. Then we go through R2 from positive to negative, so that's a drop of VR2 volts. So we have VR2 is equal to 5 volts. Thanks for watching, I hope you learned something.